Now we go to HKDSE year 2013. This question appears on revision exercise 10, question 52. Okay. First, differentiate this one. Okay. And then show that this. You should remember this formula, but it asks you to prove. Okay. I will prove it later. Okay. But I can use this result. Why in part A we have to prove this? Because in part B and part C we may use this result. Okay. I said using A and a suitable substitution to prove that this one. Okay. The substitution, I may think that the substitution, this is of the form of x squared minus a squared, right? So you will let x be secant theta, a secant theta, okay? A secant theta, and then you can solve it. And then you will get this result. I will not do it now because it is simple, okay? I just want to outline how to do it. B1, okay? So you see that there are numbers here, definite integral and indefinite integrals. And then this is not u squared minus 1. But if you know that it is by computing square, x to the power 4 plus 4x squared plus 3, you can make it as x squared minus 2 4x squared. I will write this one, okay? Yeah, I do know that you may know that 2x plus 2 squared. Okay, you have to minus 2 squared plus 3. So it becomes x squared plus 2, okay, all squared minus 1, okay? Then of course you will let u be x squared plus 2, and then you will get exactly this one, this form, except that there's 2x here. I'm going to solve the 2x, but you know that du equals to 2x dx. Very good. And then once you can replace it. But now I check that when x equals to 1, u equals to 3. When x equals to 0, u equals to 2, okay? And now I change it 1 over this one over x squared plus 2 all squared minus 1 2x dx, okay? I'm now going to change it. This one becomes 2 to 3, okay? And then 1 over what u squared minus 1. This is exactly du, okay? You see that the answer should be evaluate at 3 and 2 log u plus what u squared minus 1, okay? Is this the answer? It seems that it is not the answer, but try to do it, okay? 3 plus 9 would 8, okay? Minus log 2 plus would 3, okay? Put the 3 inside and then put the 2 inside minus each other. You see that it is different. There are 2 logs here, and the solution, there's only 1 log. So you combine it, 8 over 2 plus root 3, okay? And now you should notice that you should multiply by its conjugate, 2 minus root 3, 2 minus root 3, okay? You see that the denominator, which is 2 squared minus 3, which is 1, okay, log over 1, you don't have to write it. So here is 6 plus 2 would 8 minus 3 would 3 minus would 24. Okay, and then you see that this is 1. Okay, this is 1. 6. Okay, you got the 6. 6. Okay, you got the 6. And then 2, 4 would 2. This is 4 would 2. Okay, yellow. Minus 3 would 3. This is my 2 would 24. Okay, done. Okay, proved. And part C, you let tangent phi equals to this one, and show that d phi dt, okay, d phi dt, you differentiate both sides with respect to t, dt dt equals to d, d dt tangent phi. Okay, that is 1 here. D tangent phi becomes secant square phi d phi dt. Okay, so d phi dt is 1 over secant square phi. Okay, 1 over secant square phi. It seems that it is not t, but you know that if t is tangent phi, t square plus 1 is tangent square phi plus 1. So secant square phi is t square plus 1. So the answer is 1 over t square plus 1. Okay, done. Done this part. And then part B, this part, hence this part, you have to change it. Change it carefully, okay, carefully. And then you should notice that integrate 0 to pi over 4 tangent phi d phi over would 1 plus 2 cosine square phi. Okay, how to do it? I noticed that let's see, think about it, how to do it. I have to change it, but how to change it? D phi, you know that d phi is equals to 1 plus t squared dt. Okay, you're going to change this, and this is t. Okay, when phi is 0, t is also 0. Okay, when phi is pi over 4, t is 1. Okay, and then I can change, this is t. Okay, I do step by step. This is 0 to 1. This is 1 plus t squared dt, and this is t. Okay, I'm going to see 1 plus, what is cosine square phi? Cosine square phi, you see that this is 1 over cosine square. 1 over cosine square phi. Okay, so cosine square phi is 1 over t square plus 1. Okay, I now change all of them, and then I think I can do it soon because it changed into all to t. Okay, dt. Okay, here I do something here. This one I change to t squared plus 1. Okay, plus 2 over t squared plus 1. Okay, this side here. Okay, and now I know that 0, 1 would t squared plus 1 over would t squared plus 3 t 1 over t squared dt. And this is, I did here, this one and this one cancel out apart. The wood side t over wood t squared plus 3 wood t squared plus 1 dt. You see that it is exactly this one. Oh, sorry, I cleaned this part. You see that this is exactly, if you expand it, this one is exactly 0 to 1 wood t squared plus 4t squared plus 3. Okay, dt t. Okay, x squared plus 4x squared plus 3. Okay, here is 2x. What, 1 to 0, okay? 0 to 1. Exactly correct. Except there's the 2. So I divide the answer to 2 here. This answer is the result of B2 divided by 2, okay? B2 divided by 2. Okay. You should notice that they're trying to teach you how to do it, okay? Trying to teach you how to do it. And then now we go back to these two parts. Okay, the part A. Okay, part A, this one, you differentiate it. Okay, I do it here. Let's see. I do it here. You differentiate this. You differentiate this becomes 1 over secant theta plus tangent theta. Differentiate secant becomes secant tangent. And differentiate tangent becomes secant square theta. Okay. You see that if you factorize the secant theta out, okay, this one becomes tangent plus secant. So this is exactly this secant theta. And you know that this is the answer. And then part B, I do it here. Part B, I clean this first, okay. This part, okay, let u becomes secant theta. Then this one is du is secant theta tangent theta d theta. Okay, this one becomes secant theta tangent theta d theta, and this one is wood secant square theta minus 1. Okay, this is tangent theta. This is tangent theta. So you now know that this is integrate secant theta. Okay, and integrate secant theta is log secant theta. Secant theta is u, and tangent theta is this one. Okay.